All right, talking about similarity. So there's a whole bunch of stuff that carried over from middle school. It was the any type of transformation. You're going to be focusing on a specific type of transformation, and that has to do with shapes, about getting bigger or smaller. That's called using a scale factor. Let's look at this vocabulary. So we've got terms of dilation. You go to the eye doctor, you get your eyes dilated, it will make your pupils get larger. So it's dilation because your small pupil grew to a larger size. You can always think of it like that. Yeah, smaller sizes moving to bigger ones. To identify similar figures. Similar, the word similar is going to be that symbol. Congruent is going to be that. Proportional is whenever we talk about having a Danny that's double the size. If we talked about every single thing, the hair on your head, if we doubled Danny and made him twice the size, his hair would be twice as long. His eyeballs would be twice the diameter. His boogers would be twice as big. His toenails would be twice as stinky. I don't know if that's true, but I made up the last one. Corresponding angles, anytime that we're looking at two shapes that are similar, let's say that these are similar, that we know this angle is congruent to that one. We know that each of the angles are going to be congruent to the other figure. Corresponding angles is if I say, I'm looking at that angle, then I'm also talking about that angle. The same thing applies to the sides. So whenever we're talking about proportionality, all we have to do is talk about corresponding sides, determine the missing side using a proportion. I like to go ahead and highlight the sides so that way I can say like this, like plum color is going to go together and the blue color is going to go together. So I could set it up like this. This is a ratio comparing one side of a triangle to its corresponding side of a triangle. That ratio is going to be equal to starting with the triangle I started with. So I can always put like number 1 and number 2. That way I can write this one first. I can write that one second. 20 and x. This is where you come across cross products. This is how you write equations that you would solve, a one-step equation. So that would look like this. 12 times x, 12x equals 3 times 20, 60. Now all we're doing is solving a one-step equation. This is to find the missing side of the other triangle. So divide by 12. X equals 5. Now you had a great question about saying, well, couldn't I just find the scale factor and then use it on the one side that I know, and then I could figure out what that is? Absolutely. Here's how you would do that. And it's not going to work all the time, so it's good to know all of the skills that are required in this type of situation. So one of the main questions I was asking you for scale factor. Scale is by what fraction is it growing or shrinking by? Is it enlarging or decreasing by? So scale and then factor. Factor is any number that you multiply by. If you multiply by a number that's larger than 1, you get a bigger figure. If you multiply by a number that is less than 1, also known as a fraction, then you will get a smaller figure. So I always look from left to right, unless the problem defines otherwise, like the 3 by x triangle was the first triangle, and then someone did an experiment and made the second triangle 12 by 20, whatever. So think about, how do you go from 12 to 3? All right, so it got smaller. That means I'll have a fraction. So I'm just going to go ahead and write 1 over something. So how do you go from 12 to 3? How do you go from 20 to 5? Divide by 4, which is the same thing as using a scale factor of 1/4. So if it shrinks, put a 1 on top of the number that you find. That's it. Now, if we hadn't gone through the proportion part, we'd gone, okay, how do you go from 12 to 3? Okay, so divide by 4. What's 20 divided by 4? 5. Going through all the numbers and checking using your scale factor is going to be how you verify these problems. Let's go to the next part and take a look at some quadrilaterals doing the same exact thing. Now, it would be really easy to highlight all of these sides, and you already know that you could figure it out. 10 to 40 is times 4. Scale factor is times 4, so 3 times 4 is 12. We can go ahead and skip to say this is 12. Okay? But what I am going to do is I'm going to go through the entire process again. Oh my god, why are you doing that? Make sure you include corresponding sides that always has a side of x. Because what if you didn't? Let's take a look. 14 to 56. What we'd end up doing is setting up a ratio that would look like this. 10 to 40 is equal to 14 is to 56. Yes, these are equivalent ratios. They're both 1/4. We still haven't made any progress. So, what's the point? I don't know. That's why we don't do it. Just if you wanted to prove those sides are proportional, you could. But let's go ahead and use green. So the 3 and the x. Gotta have x so you can solve for it. So I'm going to go blue to blue and green to green. 10 to 40. And 3 to x. This is where you come up with your cross products and create a one-step equation. 40 times 3 is 120. Go through our process. Divide by 10. Divide by 10. X equals 12. Oh my gosh. What? Scale factor. Do it increase or decrease? Did it get bigger? Did it get smaller? Let's look. So from figure 1 to figure 2, we got bigger. By how much? How do you go from 10 to 40? Times 4. We know that it's going to be 4 because it didn't get smaller. If these figures were swapped, then we could just go like that because it got smaller, but that's not the case. It got bigger, so we know it's 4 times the size. 14 times 4, 56. 3 times 4, 12. 14 times 4, 56. We know for a fact that these are now similar, and we've proven it. So what happens whenever you get to problems that don't have pictures? Well, that would be a really good idea to draw a picture. All right, so a map has a scale of 3 centimeters is to 18 kilometers. There's one ratio right there. Okay, I'm just going to go ahead and set that up. We're comparing centimeters to kilometers. 3 to 18. If Riverside and Smithville are 54 kilometers apart, then how far are they apart on the map? Okay, so basically what we're saying is we've got a map. And then you're actually looking out a window, and you're sitting there going, oh my gosh, how far away is Riverside and Smithville? So on the map, it's actually 3 centimeters. When you're looking out there, it's 18 kilometers. So we can see that we have some sort of discrepancy here. So every 3 centimeters you see on the map is going to be equal to 18 kilometers outside. But we know that Riverside and Smithville are 54 kilometers apart. And we have no idea how many centimeters that is. Here's what I just did. I said, what are the two things I'm comparing? I set it up in a table. It would be the same thing as going like this. Okay, well, 3 and 18 is equal to x over 54. 18x equals 3 times, so 162. Then you divide by 18. And we're sitting there going like, wow, what the heck? All right, so 1836, another 8, 54, so that's times 3. So what's this times 3? 9. So we now know that 9 centimeters on the map is equal to 54 kilometers. Practice, practice, practice.